Welcome back, students. Here in this video, we are going to represent some representation of the graphs. So here some of the graphs are there. So number one, this is a graph which has vertices A, B, C, D. So here vertices are simply called as vertex. So A, B, C, D are vertices or simply called as vertex. Now the adjacent vertices are. So now we see what are the adjacent vertices from A, B, C and D. So from A, what are the adjacent vertices? So A to B, 1. So B A to B, A to C and A to D. So the adjacent vertices from A are B, C and D. So here I have mentioned B, C. Now I have taken another vertex B. So from B, what are the adjacent vertices? So B, B to A and B to D. So there is no B to C. So I am having B to A and B to D. So A and D are adjacent vertices. Next I am taking vertex C. So from C, I am having adjacent vertices. One is C to A, C to A and C to D. So A and D are adjacent vertices. Now I am taking vertex B or vertices B. So adjacent vertices from D are A, D to A, D to B and D to C. So these are the adjacent vertices. So with this help of this diagram, simply we can note the adjacent vertices. Next here there is another diagram, but what is the difference between these two diagrams? So the difference between the two diagrams is, in this diagram it is not having any directions, and this diagram it is having directions. So this is a directed graph and this is a non-directed graph. We already know non-directed graph means which has no directions and directed graph means which has directions. So now we have seen the directed graph which is having not directed graph. I have seen some of the vertex and adjacent vertices. Now I am taking directed graph. Now I am seeing whether it is having adjacent vertices or not. So now I am taking the directed graph. So here internal vertex A. From A, is there any terminal vertices? Only there is only one, that is C. So here we have to strictly follow the direction. So here A to C only there is a direction. So A if we consider, then it is having C. So A to C. Next if I take B, from B I am strictly having only A element. No other element is there from direction from B. So A. From C, any directions are there. So it is not giving this direction is not, this direction is not. So there is 0. If I consider D, D means D to A, there is a direction. D to B, there is a direction. D to C, there is a direction. So A, B, C. So here in this directed graphs, strictly we have to follow the direction. And in this undirected graph, we cannot follow the directions. We are not, we does not use any directions. So here in the directed graph, we have to use the directions, and basing on that directions only, we can see the terminal vertices. So adjacent matrix. What is the adjacent matrix of the following figure? So here you have given a figure or a diagram. Simply by using this diagram, we can draw a adjacency matrix. So here you have given A, B, C, D are 4 vertices, and I have given some of the edges. Now I can draw a adjacency matrix. I have taken AG. Now I am checking from A. Is there a self loop from A to A? No. So its value is 0. A to B, yes, 1. A to C, 1. A to D, 1. So 1, 1, 1. Now I am taking B. Is there a self loop? No. I will take from B to A. Is there a B to A? Yes, B to A, 1. Next B to B. Any self loop in between B? No, it is value becomes 0. B to C. No, there is no direction. There is no edge between B to C. Its value becomes 0. B to D. Yes, B to D is 1. So 1. Now I will consider C. So C to A. Yes, C to A is there. C to B. C to B is not there. So 0. C to C. C to C, it is having a loop. It is having, no, it is not a 0. C to D, it is having a another loop. it is not having a loop. D, adjacency matrix are undirected graph are always symmetric. They are symmetric. So this is about the adjacency matrix.